Imagine a world where clouds are not just weather, but the very skin of the planet, a place of unimaginable scale and power. Now, dive beneath those clouds. Ammonia ice, sharp as glass, whips past in banded winds that dwarf any hurricane on Earth. A world of storms churns below, vast, layered, and terrifyingly alive. This is Jupiter, a gas giant that has guarded its secrets for millennia. But now, a lone emissary from Earth, the Juno spacecraft, is peeling back the layers, revealing a universe of wonders we are only just beginning to comprehend. From a distance, Jupiter is a masterpiece of celestial art. At its visible tops, ammonia ice crystals paint the planet in brilliant white zones and darker, ruddy belts. Within this canvas, storms tower like mountains of churning gas. The most famous of these, the Great Red Spot, is an anticyclone so vast it could swallow our entire planet. For centuries, we saw it as a mere surface feature. But Juno's data reveals a staggering truth. It isn't just a stain on the surface. It plunges hundreds of kilometers deep, a colossal vertical engine drawing energy from the planet's interior, a swirling eye that has stared into the void for centuries. To see what lies beneath, Juno executes a daring looping dance over the poles. This unique orbit allows it to skim just above the cloud tops, mapping the planet's gravity and magnetism with unprecedented precision. It's listening for the subtle whispers of the deep interior, signals that travel through thousands of kilometers of dense atmosphere. Each perilous pass sharpens a portrait of a deep, dynamic world, the likes of which we've never seen. And at the poles, Juno found something utterly unexpected. Here, colossal cyclones, each the size of a continent, arrange themselves in striking geometric mosaics. A ring of 8 storms churns around a central vortex at the North Pole, while 5 encircle the south. These formations are locked together in a stable, beautiful pattern, persisting for years and completely reshaping our understanding of Jovian weather and fluid dynamics. Beneath this chaotic beauty, the winds run deep. Juno's gravity measurements, which detect tiny variations in the planet's mass distribution, point to jet streams extending an astonishing 3,000 kilometers below the visible layer. These are not surface winds. They are continent-spanning rivers of air, containing about 1% of Jupiter's entire mass, threading the planet's interior and shaping its very gravitational field. Deeper still, in regions hidden from sunlight, lightning crackles. But this isn't Earth's lightning. It occurs where water and ammonia mingle under immense pressure. Here, scientists believe a bizarre form of hail is created. Powerful updrafts fling water ice crystals into the upper atmosphere, where they are coated with ammonia vapor. They become heavy, slushy mush balls, ammonia water hail, that then plunge back into the depths. This process acts like a giant chemical conveyor, ferrying ammonia downward and profoundly altering the composition of the layers we can see from above. These storm towers literally breathe. Updrafts loft ice and chemicals, while downdrafts drag heat and altered chemistry back down. Juno's microwave radiometer, peering through the clouds, confirms this complex cycle. It maps the distribution of ammonia, finding it depleted in some areas and enriched in others, painting a picture of a vast, planet-wide weather engine cycling energy and materials through layers we're only beginning to chart. High above the storms, around the poles, auroras roar with an intensity that dwarfs our own northern lights. Jupiter's magnetic field, the most powerful in the solar system, acts as a colossal particle accelerator. It funnels charged particles into the upper atmosphere, creating glowing curtains of light. But unlike Earth's auroras, which are primarily powered by the solar wind, Jupiter's are a self-generated spectacle, powered by its own vast, rapidly rotating magnetosphere. This incredible system is fed by its own moons. Io, the most volcanically active body in the solar system, spews tons of sulfur and oxygen into space every second. This material is caught in Jupiter's magnetic field, forming a plasma torus that streams along magnetic field lines, fuel for the auroras and for powerful electromagnetic storms. Even the icy moons Europa and Ganymede play a part, creating ripples and currents within this complex magnetic environment as they orbit the giant. Beyond the moons lies another of Jupiter's subtle secrets, a faint, ethereal ring system. Unlike Saturn's bright, icy rings, Jupiter's are made of dark, fine dust. Juno's observations confirm they are constantly replenished by micrometeoroid impacts on the small inner moons, like Metis and Adrastea. This dust is then sculpted by Jupiter's gravity and magnetic field, a delicate, almost invisible structure hanging in the darkness. The planet's gravity and magnetism also sketch the outline of its mysterious interior. The subtle tugs on Juno during its close flybys hint that Jupiter's core may not be a solid, well-defined ball. Instead, the data suggests a fuzzy or diluted core, a vast region where heavy elements are mixed with the surrounding hydrogen, rather than forming a sharp boundary. Its magnetic field also holds surprises, a strange anomaly near the equator, dubbed the Great Blue Spot, and other patches that defy simple models, all clues to the complex motions happening deep below. Deeper still, the pressure becomes so immense, millions of times that of Earth's atmosphere, that it forges an exotic state of matter, metallic hydrogen. In this realm, hydrogen is so compressed it sheds its electrons and behaves like a shimmering, conductive liquid metal. The swirling of this vast metallic ocean is what likely drives the planet's powerful magnetic dynamo. And within this strange sea, helium may separate and rain downward like glittering droplets, releasing gravitational heat as it falls. Another quiet, hidden engine powering the giant from within. Juno's polar path is the key to unlocking these secrets. Its sequence of close passes, quick looks, and long looping drifts allows it to piece together a three-dimensional map of the planet, from gravity, magnetism, microwaves, and images. The picture emerging is bold and revolutionary. Deep jets, geometrically organized polar cyclones, migrating ammonia and auroras fueled from within. Each clue anchors the next, building a new model of a planet we thought we knew. Yet, profound mysteries remain. How exactly do the deep jets couple to the metallic hydrogen interior? How far down do the roots of the cyclones and the Great Red Spot truly reach? And what is the precise nature of that strange, fuzzy core? The giant is slowly giving up its secrets, but it demands patience. Juno's discoveries are not the end of the story, but the beginning of a new chapter. They lay the groundwork for upcoming missions like the European Space Agency's JUICE and NASA's Europa Clipper. While they focus on the icy moons, their findings will be understood within the context Juno has created, a new understanding of the entire Jovian system, from its stormy heart to its distant, icy worlds. Jupiter turns the leftovers of star formation into a grand laboratory, testing physics at pressures and scales we can never replicate on Earth. It is the archetype of a gas giant, and understanding its formation, its weather, and its interior guides how we read the thousands of similar worlds we are now discovering beyond our own solar system. We orbit a calm, friendly sun on a planet with comparatively gentle weather. But out there, beneath Jupiter's beautiful, violent clouds, a different kind of story is being written, ancient, vast, and electrified. We have only just begun to read it. With every orbit, Juno adds another page. We must keep looking down, through the storms, through the light, toward a hidden heart that still refuses to be simple.